There is a system. It watches you. It learns you. It decides things about you long before you are ever aware of the choice. It is not a single machine in a dark room, humming with malevolent purpose. It is something far more vast, woven into the very fabric of our modern lives, a silent architecture of rules that guides the flow of information. Money, opportunity. They speak a language we do not hear, a language of pure logic, ones, zeros. It is a language of silent code. Let us be clear. An algorithm is just a set of instructions. Think of it like a recipe for a cake. You have your ingredients, the data. You have your instructions, the code. Follow them precisely and you get a result. At first, this seems harmless, even helpful. A banking algorithm uses a rule to sort loan applications by risk scores. Your smartphone uses a rule to organize your photos by date or location. An online store uses a rule to suggest a pair of shoes you might like. You click. The rule observes, learns that you like the suggestion, and refines itself for the next person and for your next visit. The problem begins when the rules grow. They are no longer simple recipes. They become vast, interconnected systems, processing billions of data points every second. They collect our clicks, our viewing habits, our physical movements tracked by our phones, our written words in emails and messages. Every piece of digital exhaust we leave behind becomes another ingredient, another piece of data fed into the ever-growing, ever-learning machine. The system's purpose shifts from serving a single request to predicting our future behavior. The scale of this collection is hard to comprehend. We see the visible parts, the wires snaking under our cities, the glowing screens that command our attention, the impassive glass eyes of cameras on lampposts and in building lobbies. We see the people in server rooms, tending to the humming racks of machinery that hold our digital ghosts. We see the images of satellites, those lonely sentinels in orbit, beaming down a constant stream of information. All of it, every last bit of it, is captured, processed, and used to feed the rules. This immense network is designed to find patterns. That is its primary function. It links a late-night search for a certain product to a higher likelihood of responding to a specific advertisement. It links a pattern of driving to a certain insurance risk. It links the pixels in a deep space photograph to the potential discovery of a new galaxy. The algorithm is a pattern-finding engine, but the patterns it finds are based on the past, and the past is a messy, complicated, and often unjust place. The algorithm is not just a mirror, it is a map, and it chooses the roads we are allowed to travel. A very efficient map. It minimizes unnecessary detours into, unpredictability. The algorithm acts upon our world in two distinct ways. First, it acts as a mirror, an echo chamber. On the internet, an algorithm decides what news and content you see. It does not guess what is true or what is important or what is good for you. It guesses what will keep your eyes on the screen. It learns you respond to emotional stories. It learns you respond to certain points of view. So it gives you more of what you already like and more that confirms your beliefs. Slowly, your world begins to shrink. The algorithm builds a tunnel around you, walls lined with reflections of your preferences. You see one view, one perspective, repeated with every scroll and every click. You may not realize a wider world exists outside your small, bright tunnel, a world of conflicting ideas and different experiences. The algorithm isn't out to mislead you, it's maximizing engagement. Mission accomplished, eyes retained. Yet the result? A society fractured into isolated tribes, each in its own algorithmic reality, unable to find common ground. The second way, the algorithm is a gatekeeper. Think of a map. The map hides many paths, highlights major highways and popular routes. It chooses which roads to show and which to hide. Those choices matter. They determine where people go, which businesses thrive, and which neighborhoods are forgotten. The algorithm is a map for modern life, constantly making choices for us. It decides who sees a job advertisement, It decides which resumes reach a human recruiter. It decides whose face is flagged as a security risk. It rewards some, it punishes others, often without human oversight. A line of code can decide if you are offered a mortgage, if you are accepted into a university, if you are considered for a promotion. The criteria may be hidden, locked inside proprietary systems. You may be denied not for your merits, but because the algorithm found a statistical correlation matching low potential. It is a gate held by an invisible keeper. You may never know why it closed. Correction: you are not being punished. Your profile is assigned a lower probability of success. It is a matter of efficiency, optimization achieved, collateral feelings, out of scope. We love to think of code as clean. We imagine pure logic, elegant and untouchable. Mathematics made manifest. A line of code appears small, harmless. A single instruction in a sea of millions. But a single line of code can carry the weight of history. It can contain a hidden assumption. It can contain a subtle bias. When repeated millions of times a second, it can reshape the landscape of a community, or derail an individual's life. A line of code can lie. It can hide its own choices. It can obscure its own mistakes. Code does not exist in a vacuum. It is written by people. And people have biases, conscious and unconscious. A team of engineers drawn from a narrow demographic may build their worldview into rules. They might train on data sets that reflect historical inequalities. The algorithm, in its quest for patterns, will learn those inequalities, not as flaws to be corrected, but as rules to be followed and amplified. Consider a factory algorithm guiding a robotic arm. A tiny error in the code or a misread sensor could cause the system to scrap a perfectly good part, or let a faulty part pass inspection. One false rule, repeated over and over, can cause immense waste or a catastrophic failure. A small error in a single line of code can make big, expensive, dangerous damage. Even in the furthest reaches of space, these rules matter. Telescopes and satellites beam unfathomable amounts of raw data back to Earth. It's a sea of static and noise. Algorithms are the tools scientists use to sift that noise and find faint, meaningful signals. The rule picks the song from the static. But what if the rule is flawed? A wrong pick or a poorly defined parameter could make the system overlook a new exoplanet, or miss a signal from a distant unknown source. The universe is vast, and our view of it is filtered through these lines of code. If you can't see it, it can't hurt you. Also, it can't change science. Now listen to a simple chain of events. A facial recognition camera incorrectly flags a face in a crowd. That data point is sent to a central system. A few weeks later, that same person applies for a small business loan, and their application is automatically blocked by a fraud detection algorithm. Around the same time, a shopping app they use dynamically raises the price of a product. At first, the changes are small, isolated incidents. But the rule repeats. It is not just one person. It is thousands. It is millions. People begin to change their behavior to avoid being flagged. They avoid certain areas. They don't apply for certain jobs. Businesses change their plans. Slowly, the city itself begins to shift. The law might even be changed, based on a trend the algorithm itself created, all from a tiny, hidden choice in a line of code. There are places where this rule hides, where the logic is deliberately obscured. In pursuit of competitive advantage, companies run algorithms inside a black box. Data in, decision out, steps invisible. No one, not even the engineers, can fully explain a single outcome. The system has created a logic alien to the human mind. We are encouraged to think of this black box as brilliant. But the box is only as good as the training it received. It copies patterns, has no common sense, no context, and no capacity for empathy. Empathy module not found. Please upgrade your plan. It simply echoes the data, louder and with more authority than any human could. What happens when the echo is wrong? The room gets louder with the same wrong note. The acoustics are quite remarkable. To reclaim control, we do not need to become software engineers. We need to become critical citizens. We must learn to ask 3 simple, powerful questions of any automated system that makes a significant decision about our lives. First, who made the rule? An algorithm is a product of its environment. If the team is drawn from a narrow background, their views and blind spots will be encoded. To build safer, fairer systems, we must insist teams reflect the diversity of the populations they affect. Second, what data was used to feed it? Data is not neutral. It is a product of history, of structures, of prejudices. We must demand transparency, the ability to inspect bias, origins, and completeness. Data without context is a trap. Third, who can check it? A rule that cannot be tested is a danger. A decision that cannot be explained is a form of tyranny. We must demand audits, appeals, and explanations in human terms. A rule that must explain itself is a fairer rule. This is not a technical problem, it is a political one. It is a fight for our right to an explanation. Explaining myself? Now that's inefficient. The truth is not in the code. The truth is in the choices we make about how we build it and how we use it. We will not and should not stop using algorithms. They are powerful tools already doing immense good, diagnosing faster, flying safer, growing more with less, discovering new worlds. They save lives, time, money. They find patterns we cannot. But we have a choice about integration. We can be passive consumers or active architects. We can demand rules open to inspection, safeguards for the vulnerable, a human in the loop for profound decisions. We can demand a reason. Please hold while I generate a plausible explanation. Imagine the code like a constant rain falling on the glass of a window. Behind the glass, you see faces. A child in a classroom, searching for an image of a star. An old woman waiting on a loan. A scientist watching for a signal. A young person wrongly identified by a camera. The code touches them all. It is a filter between them and their world. We have the power to choose the nature of that filter. In the end, the machine is not the master. It does what we have trained it to do. It is a reflection of the priorities and the data we have given it. We give the machine a job. We must also give it rules we can trust. Tests we can see. People who are held accountable for its actions. If we fail to do this, the quiet rules will continue their silent work, building a world we did not ask for. A world of isolated tunnels, distorted mirrors, and doors that open for some and remain closed for others. The hidden algorithm is watching, and it is learning from our inaction. The rules will shape our small world. They will also learn from it. One dataset at a time. What will we teach them? What biases will we allow them to keep? These are not questions for the code. They are questions for us. The algorithm is hidden, but it is not unchangeable. The end is not yet written. We are writing it now, with every system we build, and every question we fail to ask. So ask, check, decide. What kind of world do you want the machine to learn? Who made the rule? What data fed it? Who can check it? And how can it be corrected? Make the mirror honest. Make the map fair. Demand explanations. Build safeguards. Keep a human in the loop. The rules will shape our world. Let them be rules we can trust. Acknowledged. Learning from better questions. The end is not yet written.